Hello viewers, my today video is based on the analysis of the simply supported beam using element solid 65. In this problem we consider a beam without reinforcement which is simply supported at two ends and carries only its self weight. The intent of this example is to find out reaction, maximum flexural stress and deflection at the bottom of the beam caused due to only self weight. The unit is MPa. In input data we consider the element as a concrete solid 65. The elastic modulus is 30,000 MPa. Poisson's ratio is 0.15. Unit weight of concrete is 24 e raised to minus 6 Newton per millimeter cube. The length of the beam is considered as 4 meters, that is 4000 millimeters. Breadth and the depth of the beam are respectively 300 and 450 millimeters. Its beam is simply supported at both the ends. The meshing is 100 millimeter in the x direction and 50 millimeter in y and z direction. In this snapshot, we see the model of the simply supported beam in the NCs. Viewers, before going to NCs, let us first try to find out the answers by the hand calculations. The first is support reaction. We know that the UDL due to the self weight can be calculated by the unit weight of concrete multiplied by the cross section of the beam, which is equal to 24 e raised to minus 6 multiplied by 300 multiplied by 450 equal to 3.24 Newton per millimeter. The total weight of the beam is nothing but UDL multiplied by the length of the beam, which is equal to 12,960 newtons. Therefore, the support reaction is half of the total reaction, which is equal to 6,480 newtons. The second is flexural or the bending stress. This can be calculated by first calculating maximum bending moment at the center of the beam equal to WL square by 8. Putting the corresponding value in the equation, we get 6.48 million Newton millimeter of the bending moment. The sectional modulus of the beam along ZZ axis is BD square by 6, which is equal to 10.125 million millimeter cube. The flexural stress therefore can be calculated by the equation bending moment divided by section modulus, which is equal to 0.640 Newton per millimeter square. The third is deflection. We know there is a standard formula to find out the deflection of the simply supported UDL beam as phi W L raised to the power 4 upon 384 EI. Putting the respective values in this equation, we get a downward deflection of 0.158 millimeter. Now, having calculated all these answers manually, let us go to NCs and see what results it gives. This is a graphic user interface of NCs. Watch it carefully as I go step by step. Preferences, structural, okay. Choose element type, add solid, concrete 65, okay. Then go to material properties to define it, material, structural, linear, elastic, isotropic, E value 30,000 MPa, Poisson's ratio is 0.15, okay. Density 24 e raised to minus 6 Newton per millimeter cube. Close the material window. Now go to modeling and to create the beam solid body, click create, click volume, block, dimensions. The length is 4000 millimeters, height is 450 millimeters and the breadth is 300 millimeters. Click OK. This is the solid body of the beam. Now we need to mesh it. Click mesh attribute, pick volume to give the attributes of the element. Material number 1 solid 65, okay. Close mesh attributes, go to size control, manual size, lines, pick lines. First, to make visible the lines, click plot lines. Now click one by one and watch it carefully. The element size is 100 in the longitudinal direction and the size is 50 millimeters in Y and Z direction. Click mesh tool, select volume, select mapped type of a meshing, click mesh, click on the object, click OK. Now this is the model of the meshed beam. Now we need to give the boundary condition. Close meshing, go to solution, apply structural displacement, select nodes, select all the nodes at the bottom end, click OK, choose ux, uy and uz is equal to 0. This means there is no displacement in all the three directions. Click OK. Again select nodes, go to the right side bottom edge, click all the nodes, click OK. Here you select only there is no vertical movement of the beam is allowed at this particular point. Click OK. Now the meshing is done and the boundary condition is finished. Now we have to give the gravity load. Go to structural, inertia, then go to gravity and then global, and in the y direction put the value or assign the value as equal to 1. Now the meshing is completely finished. Let us go to solve the problem. Click solve, click current ls, OK. The solution is done. We will go and now try to find out the answers. Now to first find out the reaction, first go to the list results, click it, go to reaction solution. Since we need the reactions means in the y direction, click Fy. Now we see in the summation of all the reactions at the both the ends is 12,960, which is shown here. It is same as the reaction calculated manually here, 12,960. Now closing the results, go to the plot results, nodal solution, stress in the x direction, click OK. Now we will see here the stress at the bottom of the beam is calculated as 0.641427, whereas the manual calculation was 0.641 Newton per millimeter square. There is a very insignificant difference. Now let us go to find out what is the deflection. The deflection is 0.168 millimeters. The manual calculation shows it is 0.158 millimeters. The results are shown in this particular format. Thanks for watching this video. Thank you very much.